Starting with some transformations, so this is where I'm talking about when they're shifting left or right, up or down. So it's very easy, so have a look. The first one is when it's shifting up, okay? So the form is y equals to x squared plus c. Now c is the amount of units that it's going up by, okay? So see how the parabolas have actually moved up? So if the original graph is looking like this, if this is the original parabola, which has the form of y equals to just x squared, okay, you should already know how to draw that one. And if we're lifting up by a unit of c, okay, so c amount, we simply lift up by that amount. Okay, and that's all there is, just lift it up, and that's the answer. Okay, so I'll show you the graph just like that. Okay, so very simple. So the other one is obviously when it's shifting down. Okay, so this is in the form of y equals to x squared minus c. Okay, so when we're shifting down by a unit of c. Okay, so again, if the original graph is at this one here, which is y equals to x squared graph. Okay, again, you should know what this graph is. This is the original parabola, and the new graph is when I lift down by c units. That's all there is, just lift it down, or actually push it down. Okay, so have a look and compare these two. Okay, so hopefully it's pretty straightforward. And you should also see that when it lifts up by c units, the intercept of y, or you can call it the vertex as well, the vertex just lifts up. So the so the coordinates of this vertex would be 0 because it's just there. So x is 0, at the x coordinate is 0. But because I've lifted it up by c, the y coordinate becomes c. Okay, so you should also know how the vertex works. And obviously this one, again, the x coordinate of the vertex is going to be 0, whereas the y coordinate is going to be going down by c, so negative c, which is going to be like that. So that's the coordinates of the vertex for this one. Okay, and we can also say that's the y-intercept. Alright, so make sure you also know these as well. Now the next one I'm going to show you is when we're moving left or right. Okay, so this one is in the form of y equals to x plus c, the whole thing squared. Okay, as you can see, that's the form. And you can see that I shifted to the left by c units. Okay, so this time you push to the left by that unit of c. Okay, so again, it's very, very simple. So if you like, I'll draw you the original graph. This is the original graph of y equals to just x squared. Okay, so if we're adding some amount to x and then squaring the whole thing, just remember we're pushing it to the left. Okay, adding left. Okay, so that's again very simple. And you should also notice that this x-intercept, or the vertex, will shift as well, so it will change. So yes, you can call it the vertex or you can call it the x-intercept. In this case, it's going to be minus c because I shifted to the left. Okay, so if you want the specific coordinates, again this time the x changes, doesn't it? The x changes to negative c. So I'm going to make x negative c, and then the y coordinate will just be 0. Okay, because it's on the x-axis. So that's the coordinates of the vertex. Okay, very simple. Now this time when we're shifting to the right, okay, so you can see the difference. This time we're subtracting c. So x minus c, the whole thing squared, is when we shift to the right by c units. Okay, so just again, you can see it very clearly. That's what it looks like. So again, I'll just draw you the original graph, which is the y equals to x squared graph. Okay, and to just x, if I subtract minus c, subtract c and square the whole value, we're going to be shifting to the right by c units. Okay, and you can also see that the vertex changes because we're moving by c units. So see how the x changes? So this time the x coordinate will be c and the y will remain as 0. Okay, so those are the vertices, or you can also call it the x-intercepts. So have a look at that. So just the 4 that I talked about just then is all you need to know. Okay, shifting up or down and shifting left or right. Okay, so adding left, subtracting to the right. Just remember those 4 concepts. okay, lifting up and down as well. So let's try some questions, starting with question 1. Okay, this question says sketch y equals to x squared plus 1. So hopefully most of you can tell me which way I'm going to be shifting. Okay, up, down, left or right. So first of all, what I'm going to do is have a look at this. It's just x squared, and to x squared, I'm just going to be adding 1. Okay, so this means that the vertex will be lifting up, so 0, 1. Okay, if I'm just adding 1 to the original graph of x squared, that means I'm lifting up. So the vertex will be changing to 0, 1. Okay, so that's my vertex. I'm just going to state the vertex first. Or if you like, remember how I said the vertex is going to be actually the same as the y-intercept in this case. So you can just substitute x equals to 0, and you'll see that y will be just 1. So the y-intercept is 1, which means the vertex is also at 1. But remember, you need a coordinate specifically, so it's going to be 0, 1 for the vertex. Okay, so now I'm just going to point the vertex there. And we should also know that the graph is concave up, so it's a happy face parabola, okay, because the coefficient of x squared is positive, which means it's going to be, okay, happy, all right? If it's negative, you know that it's going to be sad, which is concave down. So this one is concave up, so I'm just going to draw the graph like that, and that's all there is to it. So it's very, very simple. And you should realize that all I did was shift up by 1 to x squared, okay? So up by 1 unit, so it's very, very simple. Question 2, very straightforward as well. The only difference to the previous question is that I'm subtracting 1. So what can you guys tell me? Well, the vertex is going to go down by 1, okay, because we're subtracting 1. So the vertex, which was already originally 0, 0 for the y equals to x squared graph, the y will go down by 1. So it's going to be 0, negative 1 as the coordinates of the vertex. So I'll just plot it there. Okay, and you should also know that in this kind of case, the y-intercept is the same as the vertex. So you can substitute x equals to 0 to find that y equals to negative 1, and that's how I also get that one. It should be the same. So I'm also going to state that the x-intercepts when y equals to 0, because it's shifted down, the graph will all shift down, which means we're going to have some values of x for the intercepts, don't we? So what I'm going to do is find the x-intercepts. So substitute y equals to 0, like that, so x squared minus 1 is 0. And I'm just going to move 1 to the other side. And we know that x is going to be plus or minus 1. Okay, don't forget the plus or minus. Okay, it's going to be 2 values. So those are going to be my x-intercepts, negative 1 and 1. So it's going to pass through all these points, and remember that's the vertex. And we should also know that the graph is concave up again, so it's happy again, because the coefficient of x squared is positive. So all I need to do is just join those points and make it a happy concave up parabola. Okay, so can you see that? So because we shifted down, we have some intercepts for the x. So that's all there is again, so very simple. Question 3, so y equals to negative x squared plus 1, okay? Now the negative in front of x squared, don't worry about that too much yet. I'll talk about that later. Hope you guys already know what that means though. All we're doing is adding 1. So if I'm adding some number, we know that we're going up, aren't we? So the vertex will go up as well, the y value of the vertex. So see how the y is now 1? So that's going to be the vertex. And again, you can find it by substituting x equals to 0. Okay, and you can see that y equals to 1. So the vertex is also at 0, 1. All right. Now, what I'm going to do now is find the x-intercepts when y equals to 0. So just sub in y equals to 0 and solve it. Solve for x. So I know that if I move x squared over here, we know that 1 equals to x squared, right? Positive x squared. So I'll just switch those around and made it x squared equals to 1. Okay, just some simple algebra. And again, x is going to be plus or minus 1. Similar to the previous question is plus or minus, don't forget that. So we know that that's our intercepts, okay, negative 1 and 1. Now we look at the coefficient of x squared. It's negative. So what did I say when it's negative? It's going to be concave down. It's going to be a sad face parabola. Okay, so just join those points and make sure it's going downwards, and that's your graph. Okay, so again, hope those steps are pretty straightforward. Have a look. Okay, question 4, y equals to negative x squared minus 1. So again, just ignore the negative in front of the x squared for a moment. We'll worry about that later. Just have a look at what's following. It's minus 1, which means we're going down by 1, isn't it? If we're subtracting, we're going down. So our vertex, the y value of the vertex, will also go down by 1. And again, you can find that by substituting x equals to 0. Okay, so y is going to be 0, negative 1. So if it's just lifting up or down, the x coordinate of the vertex is always going to be 0. And the y would just change depending on the number we're adding or subtracting. Okay, so that's why this is negative 1. Just plot it in. And then now we're going to consider our concavity, which is going to be concave down because negative in front of our x squared. Okay, so have a look. If it's negative in front of our x squared, the coefficient is negative. It's simply going to go down by, sad face, okay? So concave down. So that's what it's going to look like. And I hope you guys realize why I didn't consider any x-intercepts. Obviously you can see now that there is no x-intercepts, but have a look. If you like, you can try and figure it out. So I'm going to substitute y equals to 0, because that's what we do to find our x-intercepts. Okay, and I'll just move my negative x squared over to the other side so I can solve for x. So negative x squared, if I move it, it's just going to be positive x squared. Now have a look here. Can x squared be a negative number? Okay, x squared, something squared is always positive, so we cannot solve this equation. Okay, x squared cannot be negative, so therefore we have no coordinates of the x-intercepts. Okay, so that's why we just ignore the x-intercepts for this one, because we know that there's not going to be any. Okay, so that was again hopefully pretty simple. Have a look. Okay, question 5. Now it's a little bit different because this time we're having y equals to x minus 1, the whole thing squared. What can you guys tell me about this one? If it's x minus 1, the whole thing squared, what do you remember if we're subtracting 1 to x and then squaring the whole thing? If we're subtracting, our vertex will be this way, going to the right, remember? So our vertex will also, if we're going to the right, we're going in a positive direction, right? So our vertex will also change to a positive direction. But if we're moving left or right, remember our x-intercept changes, whereas the x coordinates will change, whereas the y will stay as 0. Okay, because we're just moving left or right and that's all we're doing. So in this case, we're subtracting 1. This is a little bit different to when we're moving up or down, because up or down was pretty simple, because when we add something, we go up. When we subtract something, we go down. But some of you may be confused with this one, because when we're subtracting, we're actually moving to the positive direction, okay, which means the right side. So for subtracting 1, move to the right, which is the positive direction, so the vertex will also change to 1, 0. Okay? That's pretty much it. Or, if you like, remember how I said in the beginning, the x-intercept is basically what the vertex is in this case. So you can simply find the x-intercept by letting y equals to 0, and you probably find that x equals to 1. Okay, so hopefully you understand what I'm talking about there. So that's going to be the vertex, shifting to the right by 1. And now we're going to find the y-intercept when x equals to 0. Okay, so it's important to find your intercepts if you can. So sub in x equals to 0, just like that. So 0 minus 1 is negative 1. Negative 1 squared is just going to be positive 1. So our y-intercept is going to be 1. Okay, so always find your intercepts. Okay, even if they don't exist, please try it and see if they actually do exist or not. So I just did that to find my y-intercept. And, well, remember how I told you the vertex is basically the x-intercept, so I don't have to go looking for that because I've already found it. And we know that the graph is concave up. It's going to be a happy parabola, okay, because x is positive, okay, and all the coefficients are positive, okay. So because x is a coefficient of positive 1, we're just going to be having a happy face parabola, and that's what it's going to look like, and make sure it passes all these, obviously. Okay, so that's the question for, so that's the answer for question 5, and you can see how it shifts to the right when we're subtracting by 1 unit. Okay. Question 6, so we have y equals to x plus 1 the whole thing squared. So it's similar to the previous question, but the only difference is that we're adding 1. Okay, adding 1 to x and then squaring the whole thing. So have a look. Previously we shifted to the right, but if we're adding 1, we shift to the left. Okay, so our vertex will also be shifted to the negative side because left is negative, isn't it? So just don't get confused with that. If we're adding left, which means the negative side. So that's a little bit of a confusion for some of you, but just make sure you get that right. So x plus 1, which means we're shifting this way to the negative side. So our coordinates for the vertex of x will also become shifted to the negative side, which is going to be -1. Okay, and remember y stays the same. And again, as I said before, you can just find this because I said the vertex will be same as the x-intercept. You can just sub in y equals to 0 and solve for x, and you should get -1. Okay, but I won't go through that process. But anyway, that's the vertex, so just plot it in. So you can see that we've shifted to the left. And we'll find the y-intercept, just sub in x equals to 0, very simple step. Just sub in 0 and you're going to get 1. Okay, and just plot it in. And what about the concavity? Hope you guys can tell me it's just simply concave up because x has a positive coefficient. Okay, so the graph is just looking like that. Happy, okay, concave up, passing through those points. Alright, so that's question 6. Question 7. Okay, this one is a little bit different because of that negative sign. Now hopefully most of you know what that indicates, but I'll just ignore that for now. I'll worry about that later. Okay, just ignore that for now, guys, for those who are confused. For those who do know, excellent. Now just look at the inside of the brackets. X plus 1. If we're adding 1, we know that we are shifting to the left, so the vertex will become 1 less. Okay, so for the x, we just subtract 1, which becomes -1 and 0. Okay, because if we're adding, we're shifting to the left, which is the negative side. So that's why it becomes a -1. Hope you already know that though. So that's my vertex. And now we're going to find the y-intercept. Just sub in x equals to 0, just like that. 0 plus 1 is 1. 1 squared is 1. So if we have a negative in front, it's just going to be -1. Okay, so just sub it in. Plot it in. And then we're going to now consider our concavity, and that's where the negative comes into place. Okay, so what can you guys tell me about that negative? What does that indicate? It indicates that the graph is concave down. It's going to be a sad parabola. So looking like this. Okay, so if you have a negative in front of the whole thing like that, that just means it's negative like that. Sad. So that's what the graph looks like. Okay, have a good look at that. Now question 8, again very similar to the previous question. The only difference is that we're subtracting 1 to x. And you see that the negative stays there, so you guys all should know what that indicates. So first of all, let's consider the vertex. We're subtracting 1 from x, so our vertex will be going to the positive direction. Remember guys, if we're subtracting 1, we're shifting to the right, which is the positive direction. So we add 1 to 0, which was the original vertex. So the x coordinate of the vertex becomes 1. Okay, so remember y always stays as 0. So that's our vertex, just plot it. Now, find the y-intercepts when x equals to 0. Just sub in x equals to 0. This should be the most easiest step for you guys. 0 plus 1 squared is 1. Stick the negative in front, it's going to be -1. Just plot in -1. And now we consider our concavity. All of you guys should tell me that it is concave down because of that negative. Okay, so it's going to be a sad face parabola. Just join those points and make sure it's negative, so going downwards, and that's it, that's the graph. Okay, so have a look at that. And that actually concludes this section of transformations, and that's pretty much all you need to know about it. So you make sure you remember how it goes up or down, left or right. Just remember those 4 key steps. Okay.